Hello and welcome to dotnetgurukul.com. Today is the 7th session of SQL Server. Here are the agenda items. Like we will go through SQL Server 2022 data types. We will go through each and every data types in detail. Like we'll go through some examples of all the data types as well. So nothing but the different formats that the data can store for a particular data type, its ranges, and some of the examples as well. Keys and constraints, like we have something called as primary key, foreign key, unique key, check, default, and not null. These are the keys and constraints that we can impose on a particular column of a particular data type. So we will go through the keys and constraints in detail as well. And type conversation, we'll have some implicit and explicit conversations, like we'll go through cast, convert, and we'll also go through try cast and try convert as well. And some lab examples in terms of the complete data types in detail and examples and type conversions with some examples as well. So this is the agenda of the 7th session. Let's get started. So first we will go through the numeric data types. So we have something called as bit, tiny int, small int, and big int. So here are the range, lower range and the higher range. For bit, we have 0 to 1, and for tiny int, for 0 to 225, small int, big int, and big int, here are the ranges. So here are the categories, like here are the categories of the integer data types, and we also have the decimal, numeric, float, and also we have small int, small money, and money as well. So I will get this into details, like I will open my tab. Okay, now let's see each of the data types in detail. So we have data types. In data types, we have numeric data types, right? In numeric data types, we have bit. Okay, bit is nothing but it can store zeros and ones. Okay, and we have the tiny int. Let me put the slate over here. 1 second. Okay, this is convenient for me. Okay, now that bit can store 0 to 1, and tiny we have the specific 0 to 255, and we have small int, and big int. These are the specific categories, like this. These are the specific same categories, like that falls on integer type, and with a specific lower and higher range as per the shown in the table. Okay, and let's see now. We have something called as decimal, numeric, this two falls under some same category. With this will have some precision and scale. We will go through this in detail on what is precision and scale. And float for rounding off, we have something called as rounding of decimals. Okay, now we will see we on to the bit, tiny. It is straightforward. The integer on this first categories, like it has a specific lower and the higher value. So on the table, if you can see, so this first type, 5 types of integer types are very straightforward. It has lower integer and higher integer. So you may not remember all these particular ranges, but you have to understand, like big integer has the more range compared to the integer. So it is something like in this format, like bit, tiny int, small int, and big int. Okay, and big int is the highest range of all this particular thing. Okay, now coming to the numeric and decimal and numeric, what we have to know what is precision and a scale. Okay, the declaration of any particular decimal will be something like p comma s. P is nothing but the precision and S is nothing but the scale. Now P is nothing but the total number of digits. Let me tell you first of all what is a decimal. Decimal is nothing but the fraction of storing of data. Nothing but if I say what is your height, then you say that 80.5 kgs. Let's say weight 80.5 kgs, height let's say 5.9. Okay, so you say something, it is like in the form of decimals, right? So in this particular form of data, we'll store in the form of decimals, and that declaration should be in the form of P and S. P and F, P is nothing but the precision, and S is nothing but this scale. So P is the total number of digits it can have onto the left and the right side. Onto the left and the right side, on the total number of digits onto the left and right it can have is nothing but P, and the total number of digits onto the right side after the decimal is nothing but the scale. So I will write it down, and once I give the example it will be more clear. P stands for precision. It is nothing but the total number of digits both on the left and right side of the decimal. Okay, this is nothing but the precision. And what is scale? Number of digits onto the right side of after the decimal. Okay, it is nothing but the number of digits that can store onto the right side of the decimal. This is nothing but the precision, nothing but the scale. So now that we understand what is precision and what is scale, okay, now let we go through some examples. Like once we go through one example, you get to understand in much better way. Let's say I say that decimal of 5,2. So what will be the for values for this? Like let's say the total number of digits it can have is 5. Okay, nothing but let's say, and the total number of digits it can each after the decimal is 2. Okay, nothing but here total is 5, nothing but it is the precision, and the total number of digits scale is 2. After this particular decimal it is 2, right? So it can have 2. So nothing but it is a valid. Let's say I'll give another example, minus 12.34. So it can have less than the 5 digits, and it can have the less than 2 scale also, but not more than 5 and not more than 2. So this is also valid. And I can also say 9.0.999. Let's say it is having in the same, it is still in the, it's satisfying the rules of the decimal, like it is not exceeding more than, the total digits are not exceeding more than 5, and the scale is not exceeding more than 2. So this is also valid data. But all these are valid data. But if I say that 1 2 3 4 5 6 and I say this, here is the dot, this is the invalid data. This is invalid. Why? It is exceeding the precision. It is more, number of digits are more than 6, and the number of digits after the decimal it is 3. So total number is 6. So this is nothing but invalid. You getting my point? Like there is a rule of specification of precision and scale for a particular decimal. So this comes under the valid and invalid data. So I will go through another example. Let's say we'll take example 2. Okay, let's say a decimal of 7,3. Here I can say that it can total number of digits onto the left and the right it can have is 7. Okay, and the total number of digits after the decimal, it can have 3, right? So I can go with 1, 2, 3, 4, 5, 6, 7, and here is the dot. This is the valid data. Okay. I can go with 1, 2, 3 dot 4, 5, 6 also. It is not exceeding more than 7, and its number of digits after decimal 3, it is not exceeding 3. This is also valid data. I can go with 0.123. This is also valid because it is not exceeding more than 7, and it is not exceeding more than 3 after the scale is not exceeding more than 3, and the precision is not exceeding more than 7. Okay, if I say 1, 2, 3, 4, 5, 6, 7 dot 8, 7, definitely it is a wrong because the total number of precision, the total number of digits, it is exceeding the precision, right? So it is invalid. This is valid. This is invalid. Okay, hope you understand this, right? And there is a specific decimal way of declaration, and this is the precision and the scale. And numeric, when it comes to the numeric and decimal are both the same. It follows the same thing. When I say decimal of 5, 2 or numeric of 5, 2, both are same. Because of some compatibility issues, like with respect to the previous version, numeric is still there. But in 2022, we can use either in decimal or numeric. Anything is fine. We have to there is a specific regions of compatibility issues between decimal and numeric, but we can, for now you can understand, like we can take either decimal or numeric. Okay. Now coming to float, I can write here. I just draw a line saying okay. Now coming to float data type, it rounds up to the precision, specific precision based on the number of bits. Let's say I will draw a table, number of bits. Precision storage. Okay, number of it is 1 to, if it is 1 to 24, precision is 7 digit. It will round up to 7 digits, and the storage bytes is 4. It is 25 to 53. It can round up to 15 digits, and storage is 8 bytes. So I will give the example, and once you go through the example, it will be easy. So let's say I have float of 24, and the value is, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now here it will, as if said, like if it is like float of, it is 1 to, if it is 1 to 24, it will round up to 7 digits. So nothing but the ultimate value of this will be something this. Here is the output. So I will go through some of the examples of these data types, and I will go through in details as well. So once I go through the programming, that will be more easy for you. So for now, you must understand there are numeric data types like bit, tiny int, small int, big int. These are very straightforward with respect to the range of the lowest and the highest. Decimal and numeric, these are the works with the precision and the scale. And float with the rounding decimals. Like decimal, we have seen what is precision and scale, and what are the valid and invalid data types of so given number. Float, float of bytes, like float, if it is one in numeric value from 1 to 24, it will round up to 7 digits, and it will is 25 to 53, it will round up to 15 digits. Okay, so let's go through the programming. I have all the scripts ready, so I will it is very difficult to type all this, like in terms of each and every example, but I will make you to explain. I will go through each and every example in detail. Okay, let's get started. Okay, I'm creating a database. I'm giving the database name as something like SQL Server 2022 data types database. And I'm saying use this database. And now I'm creating a numeric data type. See here, I have taken integer, big values. Big value is nothing but big int. Okay. And small value is nothing but small int, tiny int, big. Just I'm showing just storing the data. Now I just wanted to show you that like big data has a highest range of data that can be stored. So small, like tiny int is like only 255, and the bit is just like 1 or 0. Okay, the price, and it is decimal and float. Okay, so here you can see that all the data types in stored in one table of the integer data types. Okay, now I'll go through decimal and the float in detail. Decimal and numeric. Okay, I created a particular table with ID as primary key, like okay, amount of decimal of 5,2 and numeric of 7,2. So as of I told, like decimal and numeric are almost the same thing. And decimal, like here is 5 is the precision and 2 is the scale. Here is the this particular thing have total number of digits onto the left and the right. It can have 5, and the after the decimal onto the right side, it can have 2 decimal number of decimals. Same here in the numeric. Okay, I created the table and I'm inserting some valid data. Okay, see, I have 5,2. 5,2 is like it is not exceeding more than 5 here. Okay, and after 2 it is not exceeding the scale as well. Same in the numeric as well. Numeric also it is not more than 7, and the scale is not more than 3. Okay, here also the same. This is also valid data. It is not exceeding 5, and here it is not exceeding 7. Okay, let's say here if I give this data, like it is exceeding more than 5, and here it is exceeding more than 7, it will fail, right? See here, arithmetic overflow converting numeric to the data type numeric. And here again I am taking this again, it is exceeding 5, and here it is again exceeding 7. Okay, okay, this is not exceeding 7, but it is exceeding this one, right? It will get failed. See here, it is getting exceeded. You can see still these 3 values only in this particular table. Okay, these are the numeric data types and then the decimal data types. So still what we have gone through. Okay, let's go through the float as well. Okay, I'm creating a table of float precision demo where I have float of 24 and float of 27. It will round up to the 7 digits, as if I told, like if it is above 53 to 23, it will round up to the 15 digits. Okay, so I will show this demo as well. Okay, I'm creating this table and inserting some data. Okay, let's say here 0 to 24. Okay, float of 24. Float of 24, it will round up to the 7th digit, right? 1, 2, 3, 4, 5, 6, 7, and it will be round up to this value. Okay, and here to 15, 8 digits. Let's say I will give the example, then it will be easier. See here, it is round up to the 7th value. You can see 1, 2, 3, 4, 5, 6, 8. This has been round up to the next value. Okay, here also see 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9 significant, so it is not more than 15 digits, right? So it will remain the same thing. So here, if you can see this value 5, 6, 7, 6, 8, it has carried one value and it has been round up to the next 7th digit. Okay, here if you can see 6, 6, 8, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is exactly 15. So it gives the it's giving the exact value. Okay. Similarly, it is also same thing. So here you can see it is rounding up to the it is rounding up to the 7 digits. Okay, it is rounding up to the 17 digits, and if the value is too much high, let's say I give another example of, let's say, for it is, since this is in the power, like it might not be that much suitable example, so I will take another one. Okay, let I take this value. I will go to 16 digits. Okay, 7. I will 7 8 1 2 3 4 5 6 7 8 9 0. Okay, 7 8 9 10. And it will double 9. Let's say it will round up to the that I will give this one as 6. 15 digits, it will round up to the 15 digits, right? So let I take this value. Let I observe 6 1. So it has the, I have given more than 16 digits, right? More than 15, right? It will round up to the 15 digits. So 7 8 9 10 11 12 13 14 15. Now you got me. So it is rounding up to the, it rounded till here only. These values has been not available. So since it has the more, it cannot, it will round up to the 15 digits. Like, since it is like float of 24. Okay, since this is a float of 24, it will rounding up to the 15 digit numerics. So this is the demo for the numeric data types. Now let's see what are character data types. In character data types, I hope you understand the integer data types, especially like decimal, float, and numeric seems to be a bit important to be noted. You can take my scripts and watch the video once again, and if you go through the execution of the scripts and practice and watch the video once again, you will get to know in detail about what are decimals, numerics, and float data types. And small money is, here is the straightforward small money. Here is the range, and I can store when they wanted to store the data money, like you can store mostly in the banking domains, so you'll be using this money data types as well. And most of the developers who don't know the ranges, they every time when there is an integer data types, I have seen developers directly choosing integer irrespective of whether it is the value, expected value is just between 1 or 100 also, they will choose integer. So make sure to, when you work, like to use which data type wisely, so that it will be more productive to your organization. Okay, so here are the integer data types. So coming to the character data types, like we have non-Unicode character data types and Unicode data types. So this non-Unicode data types will store English data, the text in the English format, nothing but the text in the English format, and this can store English as well as the other languages as well. So this is the functional difference between the Unicode and non-Unicode. Okay, I will go through, I will let me connect to the sledge. Let me connect, give me a minute. It's getting connected. Let me connect to the tab. Okay. Now it's got connected. So I was telling you, like, there are character data types. Okay. In character data types, like we have non-unique Unicode character data type, and we also have Unicode character data types. So nothing but this non-Unicode can store English characters, Here in Unicode, you can store English as well as any language characters. Okay. Now in Unicode, you have char, varchar, varchar of max. This is equivalent to text of n. Okay, this is equal to text of max. You can text of max. Okay, here you will have n char of n varchar of n, and you can have n varchar of max. That is nothing but that is equal to text of n. Okay. Here is the basic data types of characteristic like character data types. You will have non-Unicode character data types and Unicode character data types. In this non-Unicode, you will have only English characters that can be stored. Here you can store English and any language characteristics as well. So here you have char, varchar, n varchar of max, which is nothing but is equal to text. Here n char, n varchar, and n varchar of max, and that is equal to text. So this char of n is fixed length. I will explain you in detail. Whereas this both variable length. N varchar is again fixed, whereas n varchar max, and text are again variable length. Okay. So let me take an example. Let's say I declare char of 10 is equal to hello. Okay. Let's say I will declare like char of 10 is equal to hello. So since this is fixed length, it will create 10 cells irrespective of the characters, which is being characters are here only 5, right? But irrespective of the number of characters, here it will create the 10. Here the 5 spaces are left over, empty spaces, which is the 5 spaces will be padding. Padding is nothing but empty. Okay. Whereas like in the varchar of 10 is equal to hello, let's say in this slide. Here the number of characters are 5 here, but here the size is declared as 10. Here, but the size of this particular cells will be created dynamically based on the size of the characters. So not the declared size of the characters, like it is 10, right? So, but it created 5 cells and there is no space padding. So this is the basic, like how the Unicode and non-Unicode stores the data. Okay. Here in the non-Unicode also it behaves the same thing. N char of 10 and n var of 10 is equal to hello. So let's say how this will be stored and this will be stored. N varchar of 10 here it is not clear. Like I will write it again. N char of 10, n varchar of 10. Let's say it stores over here again the same way. Since this is fixed, right? So here 5 space padding. Here it exactly stores in the space, no space padding. Here is the character data types, like how we can store in the char and nchar. Only you can see this is fixed here, but this is the variable length. Here also it is fixed, and when nvarchar is like again it is variable length. But the only difference is like it stores only in the only English characters, but here it can store only English as well as other language characters as well. So hope you understand the character data types. Now let's see other data types. You also have something called as data types, datetime data types. Datetime data types, date is like to store only date only. Like here is the range from January 1, 3001 to December 31st, 9999. And for time is for only to store the time. So let's say you wanted to store in the date format, you want to store the date of your birth. So you store the date of birth. Time, like let's say if you wanted to store only the time of that particular day, so it will goes to for the hours and then minutes and then seconds to nanoseconds. So here is a range that you can store the time as well. So date time 2, you have another date time 2, like it will have a better date time, date and time. It's a combination of both date and time with a better precision. Okay, you can have a better precision as compared to this one. Okay, and you have small date time, and you'll have this particular range as well. It will extend till 2079. You also have date time, like date time and date time 2 will have the precision value differences, and you'll have also all the date time offset. Date time offset is new to us, like in terms of people who are working is in different time zones can store the date time in the with respect to the time zones as well. And here are the ranges. I will go through the examples of each character data types and date time data types, and also have the binary data types and special data types as well. So let's go through the SQL and get into the details. So I'm creating a table here. Here, this is the I'm going through this particular Unicode character data types here, and I'll going through the character of n over here. See here, I'm creating a table like fixed length example. I took a column name, and I'm saying that this column name is character of 10. Okay, and I'm inserting certain values, and I am running this into this. Okay, I already inserted this data into this table now. Okay, now let's say I try to read this value. Okay, so there is an already value there. So I created it. Is the second time I'm pressing here. So yeah, hello, you getting me? I selected twice. I ran the scripts twice. So now that I can see the fixed character column is 5 with the space. Okay, now let's say a variable length of hello, nothing but varchar. Let's say I'm storing this varchar, and I'm selecting this already in object. So I already run this earlier, I guess. So I'm getting this. Even though if you understand, like it is still the same thing, right? Yeah, I'm just running this particular thing, and I got the hello. So text example. So text example is like storing data, large data, like up to 2 MB data. Now I'm saying just this is the text column. Again, I said like varchar of max is equal to text, right? So this text column is equal to varchar. Let's say varchar of max column, I declare another one. I create a table and I insert some data, and I'm reading this data. See here. Here is an example of varchar of max. Okay. When I give the scripts all to you and you practice, that will be more easy for you. So now Unicode character data types. Now we can come to Unicode character data types. Like as I've said, like this is fixed and this is variable, and you can store English and any language, right? So okay, I'm storing the here I'm storing nvarchar. Again, I'm storing the hello. So this will have the this is an example of padding of 5 spaces. Okay, nvarchar. So again, I'm storing the nqr with no padding. So this is the no padding as well. Okay. As I told, like this can store of any language, right? So I'm storing this in any language. See, I can store a unique column with any language data. I stored some data as well. So this is the examples of character data types. Let me go through other data types. So one important data types I wanted to show you. This is the one of the date time. So if you want me to go through all this, like it is very simple, but you can do it on yourself. But I will go through each and everything. That will be more comfortable. I will give this all the scripts to you. Like you can practice of yourself. So I'm creating dates. I'm creating sim, and I'm creating a table like, and I'm giving a date column with dates, some name, and I'm just storing the date here. Okay, I can only store the date here, and I'm running this date. Okay. Now this is an example of time. So I have created a column with time column, and I'm inserting the time as well. Here is the date time example. Like I can store the date and time as well. See here, I can see the date and time as well. Date time 2 also the same thing, like it has the better precision than the date time column as well. Okay, small date time with a specific precision value. So this is the one of the example, like date time offset example I showed. Like we can store any of the time zone data as well. So let's say each country will have its own time zones, and we can store the date time with respect to that particular country as well. Let me tell you, like in terms of list of time zones. Let's say I take this one. So everything is like compared with UTC. UTC is nothing but a universal time converter. So let's say South America or Australia, it is 9.5 hours more than UTC, and South America is less than -5. So if I select -5, nothing but this is the time zone of South America. Okay. If I go with 9 plus 845, it is the Australia. So nothing but we can store the time zone of the countries with respect to the time zones of each and every country as well. Now let me check what other data types we have. So we have binary data types and the special data types as well. Let me see that one also. Binary data types. See, I'm going through each and every data type. I'm creating the tables and I'm creating the respective data types for showing you in detail, right? So this is the binary data type. So let's say here it can store in the binary data, and you can also store the var binary, something like this. You can declare the binary something like this. This is the overall make you to understand the data types. So unique identifier, you will have the something like unique identifier, like it is the 128 characteristics bit size data types. Like it will generate a new GUID every time. See here, it will create a unique ID. So this is very important. Like in most of the applications, you will come across this unique IDs as well. So it will unique ID is nothing but it will generates a new ID each and every row of this particular thing. So let's say I selected another. I'm inserting another record, John 2. Okay. It will generate a new GUID. So both will be different. Okay. So you'll also have XML data. You can store something like XML data in this particular format. So if you don't know, like this is the specific format of XML. So other data types, like you'll have all the data types in one particular table. Like you can go through this. So here is the unique identifier, XML data, and geolocation. You can also store the geographical location. Let's say something like in this particular format also you can store the data types. So here is the complete list of the data types. We have seen what are numeric data types. We have seen what are decimal precision and scaling. Okay. And we've gone through each and every data types. We created tables for each and every data type, and I've shown you how the each and every data type looks like. Same for character data type, and you have character, non-Unicode, and Unicode. This is for only English, and this is for English by the other languages as well. You have seen the date times, binary data type, and special data types as well. So you always try to know much detail on the unique identifier. You come across more on this unique identifier as well. Now let's see what are primary keys, foreign key, unique key, constraint. Primary key and foreign key, like you have already seen in your last session, like then when you wanted to link two tables and establish a referential integrating between the two tables and impose the data, we will using the primary key and the foreign keys as well. And unique key constraint is like preventing duplicates on a particular column. For example, the like unique of email ID, and I wanted to make sure this particular column will have the no duplications of email IDs. So I can use the unique email. I'll go through each and every example in the scripts as well. You have check constraint, like you wanted to impose a particular impose a particular rule on a particular column, saying that particular it should be greater than 18. So when there is no data imported to that particular column, I wanted to assign some assign some default values, so I can use default constraint. So on a particular column, if I don't want it to allow null values, so I can use not null constraint. So let me go through that. So I'm creating orders table and customer table and orders table, and the customer ID, I'm taking this as a primary key, and the orders table, I'm taking this as the order ID as the primary key, and the customer ID, I'm referring to the customer ID of customer table, and I'm saying this is the referential key. Okay, here is the primary key and here is the foreign key. Okay, here is the both, let's say, primary key and the foreign keys. So unique key and constraint, like let's say I wanted this as the unique one. Okay, and I will create this table. Okay, and this is the unique key, so it cannot have duplicate values. So I will insert and I will able to record this. But again, I am repeating it the same value, which will be an invalid record. It will say some unique constraint failed, right? Okay, this is about the unique key constraint. So not null. So I created some table and with varchar of 50 name, and I'm saying that this is not null. So I will insert first the valid data, and later I will insert with null values. So it will say this is syntax. Okay, I didn't insert this one. So this cannot insert null values. So here is the simple examples of having primary keys and constraints. So here is nothing but you have some rules and imposing certain rules on a particular column. That is nothing but the keys and the constraints. Okay, so nothing to worry on that examples, like this, just it is to verify your syntax levels and a little bit hands on your concepts. Okay, Now let's see what are implicit conversions and explicit conversions. In sometimes in our databases, we have to convert one data type to another data type. So we have certain two types of conversations, like in terms of implicit conversions and explicit conversions. Implicit conversions are just automatically happens. I can show you the demos in detail. Whereas explicit conversations, like you use cast convert, or you will use try cast, or you will use try convert as well. So I will explain you much in detail as well. Okay, let me connect to my. So basically, you understand what is data type conversions. Data type conversions are nothing but we are converting one data type to the another data type. Okay. So what is the purpose of this data type conversion? Like sometimes you have to convert string to integer for specific mathematical operations. Okay, let's say I received a particular string in my in SQL, like I received an integer in the string format, nothing but the varchar. I need to convert that into specific integer to do some specific mathematical operations. Let's say I have received 1, 2, 3, and I have 1, 2, 3 in the varchar format. I need to convert that into integer, nothing but 1, 2, 3. In this particular case, I need to do some mathematical operations like 123 dot 2, that is equal to 125, some mathematical operations. I can't do that in the same format, like in this particular format, right? This is already a varchar, and I cannot do some mathematical operation with another integer. So in that particular case, there is a purpose to convert this particular one data type of varchar to integer. I need certain things as well. And another example is like I have in the particular report, let's say I received string and something like 21st August 2024. Okay, but this particular varchar I wanted to convert to a date time, and I wanted to in a specific format, something like 2024 August 21, something in different format, or something like 21st August 2024. In this particular, I will go through some of the type conversions. Okay, like or convert. Okay, so this is your type conversion should be meaningful and should have a particular purpose. So meaningful, like I can convert 1, 2, 3, 4, something like into the integer, like something. This is meaningful, right? But you cannot convert ABC varchar to integer, right? You cannot convert this. This is not meaningful. So always make sure, like when we are time converting one data type to the another data type, it should be meaningful and it should have a purpose. Okay, and it should fall into the category of the same data types. Okay, so let come in discuss in detail in terms of type conversions. We have discussed like type conversions are two types. One is like implicit conversion. Another one is explicit conversion. So in implicit conversion, I told like it is automatically assigned. When you assigned automatically, when you assign one variable to the another variable, like it can be uh, directly assigned, automatically assigned. So assigning those variables, it is automatically done. Okay. In explicit conversion, you have to use cast or convert. Okay. So what is implicit conversion? Like when when we require implicit conversion, when we can assign one data type to another data type without using cast or convert. I will show you the scenarios. Okay, and here in the explicit conversion, like you can use try cast and try convert. Okay, now when it comes to implicit conversion, I told like it is automatically done by assigning. So in this particular thing, when you are taking the lower data types to the higher data types, nothing but the lower data types to converting lower data types to higher data types, you don't get no issues, and you can directly assign. So don't worry, I will go through the examples, you'll get more understanding. But for now, you have to understand, like in terms of implicit conversion, we are converting lower data types to the higher data types. Then you doesn't need to do any of the casting or something like it is, and it will not have any issues. For example, I'm converting int to big int. So in this particular case, like integer values, like what the big integer has the higher range and the integer has the lower range, right? Big int is like all the possible values of integers can be easily assigned to the integer, right? So it is like easily assignable, and without it is done automatically. And let's say small int, so I can directly convert small int to int without any issues, like because the higher integer has the higher level range than compared to the small int. Okay, now char to varchar. So varchar has it can store any of the characters, and whatever the characters that can hold, the varchar can easily hold, right? So in that, like let's say date time. See, in this particular date, I can store that in the date time. So it is like all the higher level, all the lower data types can be easily converted to the higher level. So let's see how it works with when it comes to the lower level to when it comes to the higher data type to lower data type. When we are converting higher data type to lower data type, you may face some errors or data loss or decimal roundups. Okay, so I'm trying to tell you about the higher data types to lower data types. Now, when we trying to convert the higher data types, you might be come across like errors or data loss or decimal roundups. For example, in this particular scenario, int to big int, like we do not have any issues. But if you are trying to convert to big into integer, if this big int value is higher than that does not fit into this particular integer, it might give an error, right? If it is this value in a big int, it falls in the category of integer range, then it does not have any problem. But if the value is high, so it will definitely give an error, right? Let's say another example like ABC, like I already discussed, like ABC, I'm trying to varchar, I'm converting that into integer, it might give an error. Okay, let's say I'm converting decimal to integer. Let's say 123.45. When I convert, that might be round up to 123. So because here integer over here, so it will give the integer value only. So that data is lost here. So in this particular, we have gone through some of the type conversions. In this particular thing, like I should go for cast convert. Okay. cast, we will go through any string data type to numeric, like string data type like 123 to 123. Okay. I am converting this string data type worker to, in this particular scenario, I can use the cast. Okay. Or date time to work. So in this particular scenarios, I will be using cast. So I will go through the examples for easy understanding, and I will also go through the some of the example for try cast and try convert as well. So let me pull out my SSMS. So first I'm going through some of the implicit example. So I told, like, when we are converting lower data types to the higher data types, we do not have any issues, right? So here, when we are trying to convert integer to big int, and we do not have any problem, because integer, all the values of higher ranges of integer values can easily fit into the big int, right? So I have taken some value and I am directly assigning. See, I do not have any cast or convert any of this, and I am trying to use this. So I do not have any problem. So now let's see one example. Like, now that we have seen lower range to upper range, right? So I will do the same thing in terms of reverse way. Let's say over here I have taken the big int. So but this big int range is high, that cannot fit into the integer value. Okay. Now if you go through these particular range values in my previous slides, you will get to know. Okay. This is the first slide. So the big int range is high and the int range is like in this particular format. If I exit this particular value, that comes into the big int, so it cannot be acceptable in the integer, right? So my big int is high, which does not fit into the range of the integer. So now this will give an error. See, arithmetic overflow. Okay. Now let I come back to this thing. You please check all the ranges, which is the, at least come to an understanding like which particular data types comes under lower data types and higher data types, nothing but the ranges. Okay. Let me go through another example. Now let's say I am taking a decimal and I'm trying to convert that into the integer. So let's say I have taken an integer value and a float value. Float value I'm taking as 123.456, and I'm trying to give that to the integer value. So here there is the decimal data is lost. Let me select that and show you. See, our 123.456 has been cut off for the decimal point. Okay. I have explained that when we are trying to convert the decimal to the integer, it will give a problem. Now that we have seen that purpose meaningful, and we have seen the implicit conversion examples, and we'll go through the explicit conversion in detail using the cast and convert. Okay. So I'm going to the explicit conversion. Let me take a new window. In explicit conversion, like, I'm trying to take string to a numeric. So I cannot assign directly a string value to the integer, right? It should be converted using the cast. So I'm taking the cast and I'm trying to convert. So here is the syntax, like cast expression has the integer, the converting data type. Okay. Okay. Now 1, 2, 3 got it converted to the string, has been converted to the integer. Now you see integer is having this 1, 2, 3 value. Okay. Now let's say I wanted to convert numeric to string. These are the examples for cast. So I'm taking a numeric value and I'm trying to convert that into var. So see, I'm using cast and expression value and has the result data type. I'm taking the integer. Okay, integer value 1, 2, 3. I'm converting into the string value. See, your string value is having the 1, 2, 3 data now. Similarly, I'm taking both examples at a time. I'm converting date time to string. So date time to string, like it has a certain date time over here, and I'm that particular date time is today's date time, and I'm casting that to the worker. See, the string data types having this today's date. Okay, now string to data type. Let's say a string value, it having today's date, and I'm taking a date time and I am casting that particular that string variable to has the date time. So now that is that's the point, like where we are trying to use cast to convert one data type to the another data type. So here is one of a few examples of date time. So when it comes to the convert is like specific way of showing the specific formats of the date time. Especially you will use the convert basically when you are trying to showcase the date time in a specific format. I will show you one of the example. So let's say I have this date, today's date, and I'm converting to this date, this format. So you use convert explicitly for formatting data type. Okay. So basically, like irrespective of cost, but convert is basically you are trying to convert varchar data type to date time of a specific format. So see, you have this specific format. You have several formats like 100 formats. Here you have the convert of this particular varchar. Okay, from date time to varchar of this particular format. See, the format has been changed now. August 14. Okay, August 16, 2024. Let's say I have 101 format also. Okay, I'm selecting all the above. Okay, let's see here the format has been changed. So basically, cast convert is basically for displaying the date time in a specific format. Okay, or you can use several other formats. Okay, so other formats as well. So let me get back to the slide. So now that you have gone through implicit conversions and explicit conversions. So implicit conversions are like when we are trying to convert lower data type to the higher data types. So it is easy and it is like automatically done. So for explicit conversions, like you have to use cast or convert. Cast is like some data type to the another data type, which is exactly fits to the data type as well. For example, string 1, 2, 3 to integer. We have seen some examples. And convert is basically when we are trying to use to format the date time. So it can format your data types in different formats as well. Like also we'll see what is handling and conversion try-cast, and so I forgot that. Let me pull out that thing. So for example, when there is not a meaningful, there is no proper meaningful in that particular conversion, and I wanted to show a meaningful null exception for that. For example, there is an ABC over here, and I'm trying to convert an integer to an integer, which is a meaningful less. In this particular case, like you will see the unhandled exception, right? Like unhandled, like unuser, like you might get arithmetic flow error over here, right? So in that particular, I wanted to have the fails gracefully showing some null values. So here, if I go through this, so I have an ABC. I wanted to convert an integer. Which is which is not meaningful. So in this particular cases, like instead of using only cast, so I can use try cast. So it is a best practice when you are using cast or convert. It's the best practices to use try cast or try convert. So here is another example which I'm giving you a proper meaningful null exception, null result output as the way. Okay, null result has the output. So here you can see the cast, the purpose. So exact fit example over here. So I told you like there should be a proper purpose and exact fit for this. For example, like converting string to numeric, such as 1, 2, 3, and I'm taking that into the string. So for convert, for specific datetime formats, you will be using specific format required. So I will be using the convert. Okay. So simple example like string and datetime to for string datetime to date, string date to datetime with a specific format. Okay. So that's it for the first module of SQL Server training. So we covered 7 sessions in the first module. So here this will be the introduction to the SQL Server 2022. So the next session will be module 2, querying SQL Server 2022. Yeah, let's catch up in the next module, querying SQL Server 2022.